This animation shows the safest and most efficient and certain method of launching the tunnel boring machines or TBMs on the Alkimos seawater desalination project. Firstly, a tunnel seal is placed on the tunnel head wall. This will be used to create a watertight seal between the tunnel boring machine shields and the shaft wall. Secondly, the TBM cradle is placed on the shaft floor. This is used to align the TBM shields in the direction of the drive and in the correct levels. TBM components are delivered in manageable sizes which comply with road transport regulations. The stationary shield and forward shield are placed on the cradle and connected prior to attaching the cutter head. The cutter head is rotated to vertical and placed onto the forward shield. These TBM components must now be pushed forward to make room for the segment erector and tail shield, which are installed simultaneously here to allow for clearance within 17.5 meter diameter shaft. The first of the flying launch specific equipment to be installed is a compression ring. Tension bars are installed between the head wall and the compression ring, which are used to effectively pull the TBM towards the direction of drive until all the shields are buried inside the seal ring. Power, hydraulics, pneumatics, control systems and slurry circuits and the flying launch truss system are provided by umbilical hoses and cables to allow for smooth TBM excavation progress in a small footprint. Once the flying launch phase is complete, shaft wall heights are adjusted to allow for the difference between the TBM shield diameter and the TBM lining invert diameter. A temporary gantry is installed to provide ventilation, allow and critical grease distribution logistical support to the TBM shields. TBM lining segments are transported horizontally from the shaft to the segment erection area inside the TBM bi-trolley system. The TBM commences the cycle of excavate, ring build and extend services until it has reached the end of the initial drive, whereby sufficient room has been created to install all of the TBM backup. The temporary gantry and umbilicals are removed, the complete TBM is then installed and commissioned underground. The seal ring and rails are removed and multi-service vehicles can now be used for horizontal transportation of lining segments and other TBM supplies. At this stage the TBM launch is complete and the TBM commences conventional mixed shield tunneling operations, which will repeat in cycles all the way to the end of the tunnel. The Alliance has designed the RO building to incorporate a centralized plant switch room that facilitates enhanced safety and operational reliability. The entire RO building has been designed to provide the most efficient hydraulic solution, with the UF and RO located in a direct line. The switch room is a two-story steel frame that is clad with precast concrete panels. The switch room design incorporates false floors to simplify cable routing to the control panels. The steel frame structure is a very cost-effective solution that allows a simple and fast erection sequence. To address noise, the west wing contains the pumps and energy recovery device, while the east wing will contain the RO racks for both the first and second pass. As well as physical separation of the two zones to maximize acoustic performance, precast concrete wall panels will be used in conjunction with noise-absorbing Dura panels in the roof. Temporary works have been assessed to address the safe installation of the roof, the solar panels and ventilation systems. Here, we show the installation sequence of the RO racks for the Alkimos desalination plant, specifically the racks in the south of the RO building. The modularized RO racks will be fully assembled and tested off-site prior to preparation for transport. The Alliance will conduct routine quality inspections at the factory during the manufacture and assembly, ensuring the works are of the highest standard. This will provide greater certainty to the construction schedule by minimizing rework on site. In the prepared laydowns, the rack elements will be reassembled from the fully traceable modules. The rack shall be dressed out with the balance of pipe supports, spools, sampling lines and instruments. This allows building works to continue in parallel and minimizes construction interfaces. After inspection, the fully assembled racks shall be moved to the end of the RO building and placed on proprietary rails for skating into the final position. The animation shows the progressive installation of the structures, RO racks, pipework and cable trays into the building. This approach allows for safe access during installation of pipes and structures that exist between the racks and back into the pump room. Spools are progressively installed underneath the RO racks from transportable lengths forming long headers. From there, the spools connecting these under-rack headers shall be installed, tying them into the RO rack vertical manifolds. Field joints are minimized along with associated construction hazards. All pipework will be thoroughly cleaned and flushed after installation to ensure the sensitive RO membranes are protected from damage during commissioning. Once the RO racks are fully installed and the balance of building services are fitted out, the buildings can have the end walls constructed. Final leak testing of the systems can then be completed prior to handover to commissioning. The Alliance design includes doors on the eastern side of the building opposite each RO rack. Human factors analysis and the health and safety of maintenance crews whilst removing pressure vessels has influenced the design, resulting in this outcome. Maintenance crews set up inside the building and outside in elevated work platforms. A mobile crane has the ability to extend through the opening to safely lift and carry the weight of the pressure vessels. The crew can transfer the pressure vessels out of the racks for replacement as required. Conventional mixed shield tunneling operations continue with the use of precast concrete lining segments. As the TBM approaches the location for the vertical risers, special super duplex steel segments are included into the tunnel lining. This process is repeated every 6 rings to allow for the drilling of the 6 vertical risers. On completion of the tunnel, the TBM backup and gantries are decommissioned and retrieved to the surface back through the tunnel. The balance of salvageable equipment is recovered from the TBM cutter head before the unit is thoroughly cleaned. A full diameter plug seal is installed to isolate the now remnant TBM and the voids permanently grout-filled, sealing the TBM from the tunnel. The tunnel is now set up for the drilling of the vertical risers. Access systems, support equipment and ventilation are reconfigured. The top ceiling structure, the riser casing pipe break, the riser TBM and the riser pipe thrust frame are all installed and commissioned. Drilling is commenced and the riser TBM advanced through the special steel segment drilling ceiling structure. Riser pipes are fed into the riser pipe thrust frame and drilling recommences. The process is repeated for the balance of riser pipe casings. Riser TBM will break through from the tunnel into the prepared marine work zone. The vertical riser pipe casings will be grouted into the formation from inside the tunnel. With the marine spread and divers mobilized, the riser will be flooded, the riser TBM recovered and the upper isolation pig installed. The riser protection collar is installed to assist with the installation of the precast concrete elements. Final cleanup of the seafloor will be undertaken and the precast base structure lifted into place, leveled and grouted. Further precast elements are subsequently lifted, bolted and finally grouted into place. Seabed backfilling is completed with ballast backfill and the flexible scour mats installed. Precast cap with screens and access cover is lifted into place. The copper nickel riser pipe installed and grouted into place. The process is repeat for the balance of intake structures, making ready for flooding once onshore facilities are ready and the isolation pigs removed.